Afternoon. The purpose of my presentation is to develop some fundamental lessons about safety. And I want to do that by considering the circumstances surrounding the disaster that struck the Piper Alpha platform in 1988. My presentation is in 5 stages. I want to tell you first what was Piper and what happened to it. And then I'll explain a little bit about the public inquiry, which was really an accident investigation. And the major part of my talk is to consider 6 factors that I believe crucially bore on the loss of life in the disaster. And from those, I want to develop lessons about managing safety. And finally, I'll close my presentation on what I believe is the bottom line of safety. So let's start with what was Piper and what happened to it. Piper was a large offshore oil rig located about 100 miles offshore from Aberdeen. It had a traditional layout. At the south end, the drilling derrick. In the middle, a processing unit separating oil, gas, condensate. And at the far end, the white building, the accommodation block with the helicopter pad on top. Piper produced oil, gas and condensate mainly propane. It exported oil both to shore and gas to shore and condensate to shore, and crucially it was linked to 2 other platforms by both oil pipelines and gas pipelines. My life was spent in the onshore chemical industry, and therefore when I joined the public inquiry into the disaster and started to think about an oil rig out in the North Sea, in terms of emergency there were 3 things that struck me straight away. First one was the fact that it was surrounded by water, and therefore the people who worked on it did not go home at night like they do on land. And therefore in any emergency the number of people that are at risk were massively greater than an onshore refinery or chemical plant. Roughly 20 times as many people. The second factor that struck me was the question of escape. Onshore, if we have an emergency on a plant, the means of escape is the surface of the land. And the means of transport are our own legs. We just run away, and within 10 or 15 seconds we can be out of danger. But with an offshore rig, escape has to be organised. Information is needed. Will helicopters arrive? When will they arrive? Are the ships stood by? And escape has to be led. It requires leadership to take those decisions that are necessary. Do we wait for helicopters? Do we take to the water? And the third crucial difference with onshore was in terms of handling any emergency. Onshore, the first thing we call up is the local fire brigade. They come with first-class equipment, well-trained crews, and experienced officers to lead them. But on an offshore rig, you cannot whistle up the fire brigade. You tackle any emergency with what you've got on the rig and with the people you employ. If you have a fire, it's the built-in fire water system that you use, and it's the part-time firemen. There may be process workers or fitters, management of any sort. So 3 crucial differences with the onshore plant, which you will see as the disaster develops, played a critical part. What happened to Piper? Well, at 10 o'clock on the evening of 6th of July 1988, there was an explosion and a subsequent fire, and in just a few hours that platform was reduced to this. Just the base of the drilling rig end of the platform. 12,000 tons of steel was 454 feet down on the bottom of the North Sea. But more crucially, in just that few hours, 166 men died. The total death toll was 167. 1 more died of his injuries the next day. And it is because of that large death toll that there was a public inquiry into the disaster. What's a public inquiry like? It's a court of law. It's led by a judge, in this case Lord Cullen, a very senior Scottish judge. Parties are represented by counsel, by legal counsel. So for instance, the operator was represented by counsel. The survivors were represented by their own counsel. The trade unions represented it. Some of the equipment suppliers were represented because they felt their equipment might be implicated in the causes of the disaster itself. Witnesses presented evidence, and they were cross-examined by both the counsel and the judge. But the inquiry was still an accident investigation, and therefore it had exactly the same objectives as we have throughout the organisation in any accident. And that is to determine the causes of the accident, in this case, the causes of death. And secondly, to make recommendations to avoid a repetition. As I develop this presentation, and develop in particular the causes of death, you will be able to interpret what I said as criticism of parts of an organisation or individuals. That is not the purpose of my presentation, and it was not the purpose of the public inquiry. Public inquiry just had to determine what happened, why it happened, and make recommendations to avoid a repetition. So, just like an accident investigation, run like a court of law, but differing crucially from a court case. We're all used to reading the newspapers, and the prosecuting counsel gets up and, in effect, sets out for the court what the prosecution, the police, believe happened. They've worked it out from the evidence. Then the case is defended. But in a public inquiry, no one gets up and says, we've investigated, we've worked out what happened on Piper Alpha, we can tell you. The inquiry itself does that piece of detective work as you go along. And by the inquiry, I mean the judge and the 3 assessors. I was one of those assessors, and I said there were 3 of us with 3 different industrial backgrounds. Our sole job was to help the judge. Help him with the detective work to determine what happened and why. Help him to formulate recommendations. And thirdly, help him write the report. So there's the public inquiry. Let me now move on to the events of the night and the 6 factors that bore on the high death toll. As I've told you, at 10 o'clock there was an explosion. We knew it was 10 o'clock because one man had switched on the television news and the television announcer hadn't yet said anything. So we knew it was within seconds of 10 o'clock. We knew where it was, and that was in the gas compression module in the middle of the platform, in part because the divers said, well, I felt a bang from that direction, or I heard a bang from this, and we could cross the lines. But crucially, the control room operator survived. And about 30 seconds, maybe a minute before the explosion, he had a series of gas alarms from that gas compression module. And the third reason we could home in where it started was from the survivors describing damage to walls. So we knew it was 10 o'clock, we knew where it was. All the gas alarms that came up were low-lying in the module. And therefore, what had leaked was heavier than air, not natural gas, lighter. So it was propane that leaked. And it is for that reason that the inquiry concentrated its attention on what we'd been happening to the condensate system in the period before the explosion. Everything was running normally until about 15 minutes before, 9:45. And at that time, the pump that pressured up condensate to about 1,000 psi to inject it into the oil export line to go to shore tripped out. The night shift tried to restart the pump and failed. But there was an installed spare pump. Now the night shift knew that during that day, that spare pump had been taken for maintenance. It had been taken for a major overhaul done once every 2 years. But they also knew very little had been done to the spare pump. Yes, it had been electrically isolated. Suction and delivery valves closed, the propane blown down from the pump. But no pipework had been opened up, no slip plates had been fitted, so it should be a relatively easy and quick job to recommission the spare pump. Reconnect the electricity supply, open the suction and delivery valves, start the pump on. But the night shift were not aware that there was a second maintenance job that had been started that day on that pump. On its delivery pipework, there was a relief valve. And that relief valve had been taken off that day for an annual overhaul and a check of its set pressure. The work on the valve was not complete by 6 o'clock. The platform was trying to reduce overtime, and the contractor's employees who were doing the relief valve overhaul decided they would finish the job the next morning. The two-man contractor team, one was a supervisor. It was his first time ever acting as a supervisor. And at 6 o'clock, he took the permit to work for the relief valve work back to the control room. The process supervisor was busy with his handover. 6 o'clock was a shift change. So the contractor's supervisor signed the permit and left it on the desk. He did not check the job site before he did that. So here were two maintenance jobs. The process team knew about one. They were confident they could recommission the spare pump. They did not know about a second, which crucially was on the delivery side of the pump before the delivery valve. When they attempted to recommission the spare pump, condensate leaked from where that relief valve had been taken off. Yes, blank flanges should have been fitted. They cannot have been fitted fully and well. Why didn't the process supervisors know about that relief valve? The permit to work system is designed to do just that, to make sure that everybody who needs to know does know. When the inquiry examined what had been happening in permits to work that day, we found there were faults in the permit to work system on that fatal Wednesday evening. As I said, the contractor supervisor did not talk to the process supervisor. He did not inspect the job site. The two permits, one for the major pump overhaul, the second one for the relief valve, were not cross-referenced one to the other. And there were faults on the night. When we investigated the background to that, these were not unusual faults. Common jobs on the same piece of equipment on Piper Alpha, the permits were never cross-referenced one to the other. It was common practice for maintenance supervisors to return permits to the control room, not speak to the process supervisor, and leave them lying on the desk. Process supervisors quite frequently would sign off a permit, accepting the job back and the equipment back prior to inspecting the job site to satisfy themselves the work was complete and entirely safe. And the contractor's supervisor, I told you, was a new one. His first time ever as a supervisor. He'd had no training in the permit to work system whatsoever. Yes, he'd seen the supervisor he worked for in days gone by use the permit system, but he'd had no training. But that wasn't too unusual on Piper. Nobody else had received regular and formal training in the operation of the permit to work system. Everything was learning on the job. The problem with learning on the job is you perpetuate and accumulate errors. So here was an explosion. At the heart of it was a lack of knowledge. At the heart of it was a breakdown in a permit to work system. And it wasn't just an error on the night, it was permanently worked that way. The men on Piper Alpha did not work the permit to work system as the management had laid down. And that was in part dependent on the lack of training. So an explosion and two deficiencies: deficient permit to work system, deficient training. I said the inquiry's role was to look to the causes of death. The explosion caused very few deaths. We think maybe 2. But after the explosion, there was an oil fire. The explosion of the gas compression module blew down the firewall and damaged equipment in the oil separation unit. And there was an almost immediate, very large oil fire. I said it blew down the firewalls. So obviously in the design of the plant, it had been considered that the chances of a fire in the compression module were sufficiently large to warrant a firewall. It seems inconceivable in a gas compression module handling natural gas and condensate that the likelihood of an explosion was any less than the likelihood of a fire. But no explosion walls were installed between the modules. On Piper, in its design phase, there had never been a systematic assessment of all potential hazards, and therefore no identification that an explosion was just as likely as a fire. So there was deficient hazard analysis. The oil fire was prolonged. In fact, it lasted longer than the inventory of oil on Piper would permit it. I told you earlier that Piper was connected to 2 other platforms by oil pipelines, and the production from those pipelines was put to shore via Piper. After the initial explosion on Piper and during the subsequent fire, the other 2 platforms went on producing. And in effect, they were pumping their oil to the fire on Piper. When the inquiry asked the managers of the other platforms why they went on producing instead of shutting down, they said that they assumed that Piper would bring its emergency under control. They'd heard the maydays, they'd heard ships broadcasting that had been attracted round saying Piper's on fire, but they assumed that they would bring it under control. The initial explosion, unfortunately, put out of commission all the means of communication on Piper, so they could not talk to Piper directly. But they really had no evidence on which to make that assumption that it would be brought under control, and therefore no real justification for going on producing. But when we examine the background to that issue, we found that there had never been any training or simulated exercises in an inter-platform emergency. The three platforms connected together by both oil and gas pipes formed one system, and if one was in trouble, there must be a reaction on the other two. But there had never been a simulation exercise, so managers could work out what they might do in the face of different emergencies. So a prolonged oil fire, division hazard analysis, no explosion walls, and again, deficient training. But even the oil fire killed very few people. What did it look like? Like this. A large fire, but not totally engulfing the platform. Unfortunately, it produced a massive amount of thick black smoke that swept to the north end of the platform where all the lifeboats were located, and no one could reach a lifeboat. But it's doubtful whether that oil fire on its own, in the fire, killed many people, maybe one. But it was followed by a gas fire. The gas pipes connected Piper to the other two platforms and to shore came up in Piper in the middle of the oil fire. And as that fire played on those pipes, they gradually weakened. The gas was at about 2,000 psi, and eventually they burst, successively, one after about 25 minutes, the other two about another half hour later. Was the hazard of the gas pipes recognised? Well, yes, it was, and in particular on Piper. Just 12 months before, a young chemical engineer had been asked to consider whether it was worth renewing the contract for the small firefighting ship that stood by Piper. It could spray water onto Piper, but it wasn't very effective at fighting a fire. But this young chemical engineer, in studying this issue, examined all the potential fires that could occur on Piper. And in doing so, he examined what the fire would be like if a gas riser broke. And what he wrote about that was that if a gas riser fails into a fire, the fire will be enormous, there will be no means of containing it, and the loss of life will be very large. At the meeting of senior managers to consider his report about renewing the contract for the firefighting ship, that paragraph about the potential hazard of the gas risers was never raised. No one commented on it, no one questioned it. So here was a known hazard, a massive industry of gas in those long, large pipelines aimed at the platform, and the hazard was not managed. It wasn't a question of identification, it was a question of managing it. Could anything have been done? Well, yes, you could have had water sprays specifically on the risers that would have bought some time. You could have insulated the risers. That would pose problems because of corrosion underneath the insulation. But again, you could have bought time. Might have bought some hours that might have been crucial on that fatal night. What did the gas fire look like? It looked like this. As you can see, very different from the oil fire, the platform engulfed in fire. But this slide gives you a very poor impression of what it was like. And what I want to do is to show you a very small piece of video. In one of the ships near Piper on that evening, a Norwegian sailor had a video camera, and he was taking shots for his child's school project. And he took film of the disaster. And what I want to show you is about 30, 40 seconds of film, which starts with the oil fire, and you then see the first gas riser blow. Incredibly, some men escaped after that gas riser blew and through those flames. I said earlier that a North Sea platform has to fight a fire with whatever it's got. And on paper, it had quite a lot. In particular, it had a water deluge system that sprayed a defined amount of water over every area that could contain hydrocarbons. On the night of the disaster, the water spray system did not work at all. Now, the initial explosion, no doubt, destroyed the main power supply and therefore put out of commission the water pumps that supplied that water deluge system. But the designers of the platform had foreseen that possibility and had therefore installed emergency water pumps, diesel-driven, that started up automatically when the electrical-driven pumps failed. But on the night of the disaster, the diesel-driven pumps were not on automatic start, they were on manual start. They were on manual start because of a problem with diver safety. The water pumps took their suction from below the platform, and if a diver was close to the pump suction when it started up automatically, he or his feeder lines could be sucked into it and the diver could die. And this issue was raised with the platform manager, and quite rightly raised with him, and he decided that the diesel-driven pumps would be on manual start whenever the divers were in the water. Note, not when they were near the pump intake, whenever they were in the water. And on Piper, in the summer months, diving took place for 12 hours each day. So in the summer months, the crucial backup firewater pumps were on manual start for half the time. Platform manager absolutely right to consider the problem of the diver's safety. What was wrong was the quality of the decision he took in the face of that problem. On his sister platform, they only put the diesel pumps on manual start when the divers were close to the pump suction intakes. And that was infrequent. But even if the pumps had started up, it is most unlikely that the deluge system would have worked properly, because there had been a problem with blocking of the deluge heads. The seawater corroded the deluge pipework, the products of corrosion were carried forward and blocked the small holes in the deluge heads. First attempt to cure this was by more frequent cleaning of the pipework, but that didn't work. It just presented bare metal to be corroded. Second method tried was to put in larger heads with larger holes in them. That didn't work either. The corrosion products blocked those. And finally, it had been decided to replace all the deluge pipework in non-corrosive material. Unfortunately, by the time of the disaster, the only module that had been so converted was the drilling module, and that was the one that didn't really catch fire. Now, I think you'd agree that's a quite logical way of tackling that problem. Try one method, try increasing the holes, and finally facing the large expense of replacing the pipework. But what was not acceptable was that the problem of blocking deluge heads had been identified 4 years before the disaster, and after 4 years it had not been solved. So in terms of firefighting, the diesel-driven pumps being on manual was a deficiency of quality of safety decision. The spray heads not being fully functional and working well was a deficiency of safety management. It was well known throughout the company, but it had not been solved in any kind of reasonable time period. As I told you, the inquiry has to determine the causes of death, and the bulk of the people on Piper Alpha died in the accommodation block. As the explosion took place at 10 o'clock at night, most of the onboard crew were already in the accommodation block, and many of those working made the way there through the smoke, through the flames. And they did that because the normal means of transportation was by helicopter, and they expected rescue helicopters to come in and take them off. But they died in that accommodation, and they died of carbon monoxide poisoning from smoke. Because although the ventilation system on the accommodation block had dampeners that would close on high temperature, people kept opening doors to see what was happening, kept breaking windows to see if they could escape. Some fire doors had been permanently hooked open to facilitate passage. Had been like that for weeks. So there was no discipline in the face of that fire and the smoke, and gradually the accommodation filled up with thick smoke and the people died. We know that because one part of the accommodation block was recovered from the bottom of the sea, and there were 80 bodies in it. But they also died because they stayed there. Within minutes of the initial explosion, it must have been very evident that no helicopter had any chance of landing on Piper in the face of the flames and the smoke. The only chance anybody in the accommodation has, and it was a lousy chance, was to leave the accommodation, fight the way through the smoke and the flames, and jump in the sea and hope to be picked up. And there were many ships round doing exactly that. Unfortunately, no decision was taken to tell the men in the accommodation block to take that terrible chance, but it was a chance, and they stayed and died. None of us know how we will react under the stress of a major emergency if we were in charge. We can't forecast that. But what the inquiry noted was that the offshore installation manager had had inadequate training in handling emergencies. He hadn't gone through any simulation exercises of the types of emergencies that might develop on an offshore rig. Not his fault. If a man is appointed to a job and training is needed to fit him for that job, it is the senior management's responsibility to provide that training. That training was not provided. It was a poor chance of survival, but it was possible. 28 men left the accommodation, fought their way through the flames and smoke, jumped in the sea, and they were picked up. The final factor I want to touch on about the disaster is about auditing. The deficiencies I've told you about, they were not difficult to find in the inquiry. The problems of the permit to work system we ran over in the first fortnight. So if we found them so easily, why is it the management had not noticed them during the operation of Piper? Our way of knowing what's happening in all our organisations is by auditing. Now, we do it, required by law to do it, for finances. And equally, we audit safety practices. And on Piper, there was a lot of auditing, more than I'd been used to in my previous career in chemicals. For example, each day, one of the safety operators on the platform was required to monitor the operation of the permit to work system. And he went round looking at what people were doing and examining permit to work forms, things like that. No faults were ever reported on the permit to work system on Piper Alpha. Just 6 months previously, there had been an in-company audit of Piper. They chose 3 or 4 subjects to audit. One, again, was the permit to work system. That in-company audit said there were no faults in the operation of the permit to work system on Piper Alpha. Problem with the deluge heads. Been running for 4 years. There was an annual fire insurance audit. The inquiry read the reports for the 4 years. Not a single report noted the problem of the deluge heads, but it was a fire insurance audit. So, a lot of auditing on Piper, but deficient quality auditing. And when you have deficient quality auditing, it has a double hazard. A, you miss things that you want to pick up and correct. But secondly, it lulls the management into a false sense of security. As one very senior manager said to the inquiry, I knew everything was all right because I got no reports of things being wrong from safety auditing. In my experience, that's not real life. Safety isn't like that. There are always things that you can find that can be improved. And if you get reports that give continuous good marks, you smell a rat. So there are 6 factors and the backgrounds to them that bore on the death toll on Piper Alpha. What I want to do now is extract lessons from those. Clearly, there are lessons to learn about the detailed design and operation of permit to work systems, for example. Equally, there are lessons peculiar to the offshore industry, like planning evacuation and means of escape. But all history teaches us that the detailed circumstances of any major accident never repeat themselves. And it's for that reason that we try to get to the root causes of any accident. And when we look at the list of deficiencies that I've developed today, we can bring out 4 lessons. All the deficiencies I've talked about were the responsibility of management. So the first lesson is that safety is the responsibility of management. No one else. It's not the responsibility of the regulator or safety committees or anything like that. It is the responsibility of management. Management is a very wide term. Let's get more specific. It is the responsibility of line management. It is not the responsibility of the safety department. Safety department has a crucial role to play. It has things it must do, but it is not responsible for safety performance. That is the line management. And it is the line management from top to bottom, from the chief executive to the lowest supervisor. And in particular, the chief executive. He has to be totally committed and visibly committed. So that's the first lesson I would extract from Piper Alpha. The second lesson is that safety needs a systematic approach. If you look at all those deficiencies, they were failures in systems. Either there was a system, it didn't work well. For instance, there was a permit to work system, but it didn't work properly. Or there wasn't a system where there should have been. There was no systematic assessment of major hazards in the design of Piper Alpha. There should have been. So safety needs a systematic approach. Third lesson I extract is, it is the quality of safety management which is crucial to you. The offshore installation manager facing the problem of the divers with the pump intakes, right to face it, he had to decide what was wrong was the quality of his decision. Another example from the same manager. He told us that he walked around the platform for about an hour and a half each day. And he did that to keep his finger on the pulse, and in particular, to keep a feel of safety. Check on permits to work, look how people were doing jobs. And I think you'll all agree that was a right thing for the leader to do. But he told us he did that at 7 o'clock at night. And he did it at 7 o'clock at night because that was the only time he had available. Offshore installation manager is a very busy man. But then the bulk of the work finished at 6 o'clock. So it is not just putting the effort into safety management. It is the quality of what each one of us do. And the final lesson is about auditing. We have to know that things we decide must be done a certain way to be safe, are done that way every single time, every single day. And our way of doing that is by safety auditing. And it must be high quality safety auditing. So there are 4 fundamental lessons I would draw out of the disaster on Piper and its background. But I told you at the start that my final section of the presentation was what I call the bottom line of safety. And the way that I want to cover that is to tell you of 2 short episodes told to us by 2 of the survivors from Piper. They were both relatively young men, around 30. And the first one was very unlucky. He arrived on Piper just 6 hours before the explosion, at 4 o'clock in the afternoon. It was the first time he'd ever been on Piper Alpha. In fact, it was the first time he'd ever worked offshore. He had a short safety introduction course. He had a meal. As he was aiming to go to work at 6 o'clock in the morning, he decided to go to bed early. And he did, about 8 o'clock. And he was woken by the explosion. And he then tried to tell the inquiry how he escaped. But he suffered from a major problem. At no instant had he any idea where he was. He'd never been on the thing before. Counsel kept saying, "Where were you then?" "I don't know. I couldn't see." And eventually he found himself on a walkway. And he was surrounded by thick smoke. And then large flames came up with the smoke itself. And he told the inquiry, "I decided to jump off the walkway." And the counsel asked him why he decided to do that. And he said, "I decided it was better to die hitting the deck than to be burnt alive." He did jump. He fell straight in the sea and was rescued. And to this day, neither he nor we know where he jumped from. The second episode is from a man who worked for the drilling contractor Borden. He was on night shift when the explosion took place. He was at the drilling rig. And he fought his way through the flames and the smoke to the accommodation block. And that took him some time. And by the time he got there, the accommodation block was full of the thick black smoke. And when he got inside, he could see nothing and he could see no one. And he told the inquiry, he called out, "Is anybody from Borden here?" When counsel asked him, "Why did you call that out?" he said, "I didn't want to die alone." And I tell you those two stories because we must always remember that safety is not an intellectual exercise. It's not something to keep safety departments in work or a reason to go to conferences or hear presentations. Safety is truly a matter of life and death. And the sum and quality of all our individual contributions to the management of safety determines whether the colleagues we work with live or die. And on Piper Alpha, on the 6th of July 1988, they died.